This method can help answer key questions in the materials chemistry field and in photophysics regarding the nature of the emissive states in photoluminescent materials. The main advantage of this technique is that all emission spectra are available from 0 time to seconds of delay.
To begin, prepare 4 milliliters of a solution of the chosen luminescent compound in solvent, as described in the text protocol. Pour the solution into the degassing cuvette and close the valve. Then, connect the vacuum pump to the inlet neck of a degassing cuvette. Hold the inlet neck of the cuvette and slowly put the round bottom flask into liquid nitrogen. Shake it occasionally while the flask is in liquid nitrogen. To ensure the whole solution is frozen, shake the round bottom flask. Turn on the vacuum pump and open the inlet valve. After 10 minutes, close the inlet valve and turn off the vacuum pump. Slowly place the round bottom flask into isopropanol. Shake the cuvette occasionally until the solvent is melted. If the degassing has been successful, air coming out of the solution should be observed upon the first cycle, in the form of bubbles. Now, warm up the solution in the cuvette to room temperature. Either use a water bath or wait for the temperature to equilibrate. Turn on the laser system. After waiting about 30 minutes for the beam to be stabilized on the output pump power, use the power meter to measure the laser fluence. The reading should be approximately 100 microjoules per pulse. Now, turn on the measuring system. Turn on the 4-spec software and set up the measurement parameters, including the number of collected scans. To access the camera's control setup, choose Window, Camera. Make sure the camera is turned on by this time. The software connects with the camera now. Set the delay and the integration time for the 0 time parameters, including 981 nanoseconds of delay and 10 nanoseconds of integration time. These parameters can then be used to verify if the measurement setup is aligned. Set a trigger for -trig. Then, send the parameters to the camera with the Send It button. Now, set the slit and monochromator position appropriate to the spectral range and intensity of the sample's emission. To place a solution, fit a cuvette holder in the sample area or fit the cuvette in a cryostat if temperature control is required. Then, place the degassing cuvette into the holder and secure it using a laboratory stand. Ensure by careful observation of the photoluminescence that the laser beam hits the cuvette. After making sure that the laser beam is aligned, cover the sample unit to avoid any room light being recorded by the detector and to reduce the risk of laser scattering. To set up the experiment, cover the laser path using a shutter. Measure the background emission using the Ctrl-D shortcut. Then, open the automatic measurement script and input the name of the experiment file into the text box. Then, press Enter and input the starting line of the experiment file. Press Enter again and input the last line of the experiment file. Then, press Enter at the end to run the script. The automatic script allows the measurement of the emission at a set of different delay times given in the file. Once finished, select one spectrum and scale. Export the spectrum to the file by clicking File, Export, Curve as Text. Then, choose a name and directory. The results are now ready to be processed by the appropriate software. When all planned experiments have been finished, turn off the equipment, proceeding in the opposite order as it was turned on in. Remove the degassing cuvette from the holder. Open the inlet valve and dispose of the solution. Rinse the cuvette with acetone, taking care to wash all inner walls. Repeat the rinse 3 times. Shown here is a decay profile of a thermally activated delayed fluorescence emitter in toluene solution, and the time-resolved spectra recorded in the same experiment with a phosphorescence spectrum recorded at low temperature. prompt and delayed fluorescence can be clearly distinguished. Shown here is a decay profile of a room temperature phosphorescent molecule in a solid polymer host. Also shown is the time-resolved spectra recorded in that same experiment, with a phosphorescence spectrum recorded at low temperature.
While attempting this procedure, it's important to remember to check the condition of the plastic tap and the cuvette before starting, to ensure proper degassing of the solution. Though this method can provide insight into luminescent molecules, it can also be applied to other systems, such as excitoplexes. Don't forget that working with glass equipment under vacuum can be extremely hazardous, and precautions such as wearing goggles should always be taken while performing this procedure.